What's up, everyone? Today we're going to talk about sine and cosine graphs. So let's get into it. So sine and cosine graphs are what we call oscillating functions, meaning that they repeat themselves every so often. If you notice the difference between these two graphs, we have sine on the left and cosine on the right. The parent function starts at 0, 0, whereas the cosine parent function starts at 0, 1. So that's usually the kind of telltale sign of whether you're looking at a sine graph or a cosine graph is, does it start like in the middle, or does it start at a max or a min? If it starts in the middle, you're looking at a sine graph. If it starts at the top or bottom, or at a maximum point or a minimum point, you're looking at a cosine graph. Right, so let's dig a little bit deeper into these graphs. So we have the sine graph shown here. We're going to focus on this graph of sine, but anything we talk about can also be applied to cosine as well. So like we said, the curve repeats itself continually. So that means it's periodic. It oscillates on either side of its principal axis. So if you notice in the graph given to us, it oscillates right along the x-axis. The distance above this little hump above the x-axis is the same as the little bump below it. And so therefore, with no transformations, the principal axis of both sine and cosine is just at y equals 0 at that x-axis. In general, though, because we are going to talk about shifting the graph a little bit, in general, you can find your principal axis by averaging the y values of the max and min points. So just adding them up and dividing by 2. The amplitude of the periodic functions, so both sine and cosine, is the distance from the principal axis to the maximum or the minimum. So a key word here is distance, that it has to be positive. So in general, or for our parent functions, sine and cosine, our amplitude is always going to be 1. And you can tell that again from this graph. If you look from your principal axis at y equals 0 to the maximum point, this distance is 1. Or from the principal axis to the minimum point, that distance is also 1. So it doesn't matter whether you go up or down, because you're looking at the positive value anyway. In general, or once we have transformations going on, you can find the amplitude by finding the absolute value of the difference of the y values of the maximum and then cut in half. So you're looking at the distance from the maximum y value to the minimum y value, but then cutting it in half, since you're finding like basically the midpoint between the maxes and mins. You have to do the absolute value though, only because, like we said, the amplitude has to be positive since you're looking at a distance. And finally, the period of the function is the distance along the horizontal axis between a point and the corresponding point in the next cycle. So if we're looking at the sine graph, we said that it, with no transformations, starts at 0, 0. And if you notice, it goes up. It goes down, back through the principal axis, down to the minimum point, and then back up to the principal axis. And then it repeats itself up, all the way down and back up. So that means this is one full cycle or one period. You can also go like how it has the arrows here, max to max, min to min. Once you just see it start repeating, that's indicating that that was the closure of one period. So with sine and cosine, again, with no transformations, their period is either in 2 pi, if you're in radians, just like our x-axis is on this graph, or if you're in degrees, it's 360. But either way, it's one full circle when you don't have any other transformations. All right, so let's bring them all together in terms of transformations as well. So if you look at our sine and cosine graphs, we now have all of the kind of standard transformations that you would see. And transformations with these two graphs work the same way that they would with other transformations or with other graphs. Some of them have different names just because they're trigonometric graphs versus standard function graphs. But most of these still work the same way. Pieces on the outside of the functions or outside parentheses affect the graph vertically. pieces on the inside affect the graph horizontally. Things that are added or subtracted, like C or D, will shift the graph somehow, versus things that are being multiplied to the graph, like A and B, will stretch or compress the graph somehow. But let's talk about what all of those are and how they actually do affect these graphs. So A, in terms of standard transformations, can stretch or compress the graph vertically. It can also reflect the graph over the x-axis if it's negative. And in terms of specifically sine and cosine, in terms of these trig functions, it also provides the amplitude. So the absolute value of whatever number is out front gives you the amplitude. B, going right down the line, B still being multiplied or still multiplied to the function, but now it's inside parentheses. So in terms of standard transformations, that would mean it can horizontally stretch or compress the graph. It would mean it could reflect the graph over the y-axis. And again, both of those are still true. But now B can also affect the period, or it does affect the period. What you can do or how you can find it is the period itself will equal 2 pi divided by B, whatever that number is, or 360 divided by B if you're in degree mode. With C, since C is inside parentheses, but now being added or subtracted, it provides your horizontal shift, and same idea that in these trig graphs, it also provides the horizontal shift just for whatever reason, and I honestly don't know why. We call it a phase shift when it's in trig graphs. So instead of saying horizontal shift, or instead of asking for a horizontal shift, the question will ask for a phase shift, and it's just talking about whatever the horizontal shift is. D, added at the end outside of parentheses, again still acts as the vertical shift, but it also will give you the equation of the principal axis. So y equals D is your principal axis. Anytime you have a shift up or down, it's going to take that principal axis that was at y equals 0, and it's going to change it just to whatever that shift is.